In section 2.6, we will continue to graph sine and cosine functions. So a quick recap. The general sine wave equations are y equals to a times sine of b times the quantity x minus c plus d, or same with cosine. The period of a general sine wave is given by p equals to 2 pi over b, where b is a coefficient of this quantity. The amplitude is the absolute value of a. The phase shift is c units to the right if we have x minus c, and c units to the left if we have x plus c. And the vertical shift is just the number of units the graph is moved up or down. That's given by the letter d. So in the first example, we simply want to identify the amplitude, the period, and the phase shift. So the amplitude is going to be the absolute value of a, which is the absolute value of 9, and that is going to be 9. The period is going to be 2 pi over b. In this case, the value of b is 2. So we're going to have 2 pi over 2, which is simply going to be pi. And the phase shift, so this quantity, this is called the argument, is x minus pi over 3. So if you think about it, if you said x minus pi over 3 equals to 0, then x equals to positive pi over 3. So we have pi over 3 units to the right. And in MyOpenMath, you would just simply put positive pi over 3. Okay, let's go to the next one. The next one says, find the equation of a sine wave that is obtained by shifting the graph of y equals sine of x to the right 4 units, downward 8 units, and vertically stretched by a factor of 8, which is the amplitude. All right, so our general sine function is going to be y equals to a, which is the amplitude, times, and then we have the formula back here, times the sine of the quantity b times x minus c plus d. So let's figure out what each of these are. A is the amplitude. A is equal to positive 8. We know that. We're moving to the right 4 units. So since c is equal to 4 units to the right, remember, anytime we go to the right, it's going to be x minus c. Anytime we go to the left, it's going to be x plus c. So that would make the argument x minus 4. And then we're moving downward 8 units. So the value of d, which moves the graph up or down, is going to be negative 8. So our equation is going to be y equals to a, which is the amplitude, times the sine. Now, we don't have a period change, so b is just going to be 1. We have x minus c. So actually, we don't even need that bracket. So we're going to have x minus 4 since we're going to the right. And then d is negative 8 because we're moving down 8 units. All right, let's identify the following things given this equation. So the amplitude is the absolute value of 3. Amplitude is the absolute value of 3, which is just going to be 3. Now the period, here's where you have to be careful. Notice that if you have a 5x minus 35, then the x plus or minus c, the argument has to have a coefficient of 1 for the x. So this can't happen. We can't have the 5 there. So we're going to have to rewrite the equation. We have y equals to 3 times sine. But now we're going to have to factor out the 5 because the x can only have a coefficient of 1 as part of the argument. So we have between 5x and negative 35, we can factor out a 5 because we want that coefficient of x to be 1. And just a quick recap of when you factor out a value, factoring, this is like reverse multiplication. So when you factor something, you're actually dividing each of these by 5. So 5x divided by 5 is x, Negative 35 divided by 5 is 7. So that gives you 5 times the quantity x minus 7 plus 2. And we can verify that because if you multiply this back, you got 5x and negative 35. And once again, the reason we did that is because we want x to have a coefficient of 1, not 5. So now we know that the b value is equal to 5. That means the period is going to be 2 pi over b, which is going to be 2 pi over 5. Okay, the horizontal shift, we have x minus 7 as the argument. And if we set x minus 7 equal to 0, we get x equals to 7, which means we have 7 units to the right. Because we have x minus c, that goes to the right. And if we had x plus c, that would go to the left. Let's graph the following function. We have y equals to 2 times the cosine of x minus pi. So first, I'm going to remember that the a and d values, they affect the y, and the c and b values, they affect the x's. So first, I'm going to identify that the a value is 2. My d value is 0, so I don't have to identify that. What this tells me is that each y value is multiplied by 2. Remember, the amplitude multiplies all the y values, and if we had a plus d or minus d, you would just move that graph up or down, so you would increase or decrease the y values by that amount. All right, now our c value is pi. If you set x minus pi equal to 0, we get pi. It's x minus c, so we know we're moving to the right. So each x value is increased by pi units. So let's take a look at the x values first. I'll do this on the side. I'm going to take each x value. So our 5 key points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Once again, if you forget that, all you have to do is you got to look at the unit circle. We have 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. Just go around the circle. And then for cosine, we're taking the x value of each ordered pair. So this is 1, 0. The x value is 1. That's where we get this from. Over here, we have 0, 1. The x value is 0. That's where we get the second one from. And then here, we have negative 1, 0. So we have negative 1. This is 0, negative 1. So we have 0. And then back to 1. So for cosine of any angle on the unit circle, on the quadrantal angles, we're simply taking the x values and go around the unit circle. Okay, so all the x values get increased by pi units. So for the first one, we have 0 plus pi, which is just pi. Then we have pi over 2 plus pi. We got to get a common denominator here. So this is like saying pi over 1. And the common denominator here is going to be 2. So the first fraction doesn't change. The second fraction, because we have pi over 1, we can multiply each of these by 2. So this gives us 2 pi over 2, which is the same thing as pi over 1. And if you add pi and 2 pi, then this will give you 3 pi over 2 as my next x value. The next one should be a little bit easier. You have pi plus pi, which is going to be 2 pi. Then we have our next x value is 3 pi over 2. I'm adding pi to it. So once again, if I get a common denominator, it's going to be 2. The 3 pi stays the same because we already have a denominator of 2. But for pi, we need to multiply both the numerator and denominator by 2 to get that common denominator. So we have 3 pi plus 2 pi, which is going to give us a 5 pi over 2. And then lastly, let me make this a little more clear. And then lastly, we have our last x value for the key points is 2 pi. And if I add pi to it, this gives me 3 pi. My y values are a little bit easier. I just multiply everything by 2. So we have 1 times 2 is 2. I have 0 times 2 is 0. I have negative 1 times 2, that's negative 2. I have 0 times 2, which is 0. And then I have 1 times 2, which is 2. Okay, so my x values are going to be pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. Then my y values, I'm going to go from 2 and negative 2. So I have pi comma 2. I have 3 pi over 2 comma 0. I have 2 pi comma negative 2. Then I have 5 pi over 2 comma 0. And then back to 3 pi comma 2. And then the same, if you wanted to keep going, it would just keep going in both directions. That was horrible. Something like that. All right, last but not least, we have, we want to sketch the graph of y equals to negative 3 times sine of x plus pi over 4 minus 1. And this one we will do in class.